Now let's solve this math question, and it says given that the integral having an upper limit of k, a lower limit of 1, of x squared minus 2x plus 1 dx equals 1 over 3, where k is greater than 0, determine the value of k. Now first of all, let us take note that when you have an integral of x raised to the power of n dx, that gives us x raised to the power of n plus 1 all over n plus 1 plus what? C. Okay, alright. Now applying this rule here, we then have to be x raised to the power of 2 plus 1 all over 2 plus 1. Okay, now minus 2, then x raised to the power of 1 plus 1 all over 1 plus 1. Okay, now since here x has a power of 1, okay, so to this end, now plus here we have x raised to the power of 0 plus 1 all over 0 plus 1. Now this is a constant as 1. Alright, and to that end, for us to integrate this, now we revert it back to x, which is raised to the power of what? 0. Okay, then plus 1 all over 0 plus 1, because 1 here is x raised to the power of what? 0. Okay, now all equals to 1 all over what? 3. Now to this end, take note, here you have k and 1. To this end, here we have x raised to the power of 3, then all over 3, now minus 2x raised to the power of 2 all over 2, then plus x all over 1. Take note, k 1 equals 1 all over what? 3. Now to this end, since here we have an upper limit of k and a lower limit of 1, we tend to subtract the values of 1 from that of k. So which implies that wherever you see x, alright, okay, let me do it like this. So here we have x raised to the power of 3 all over 3 minus 2x raised to the power of 2 all over 2, then plus x, then minus x raised to the power of 3 all over 3 minus 2x raised to the power of 2 all over 2 plus x. Take note, all equals to what? 1 over what? 3. Now this is for the k and this is for 1. So it means now for every value, for every term of x, represent it or plug in k. So here we have k raised to the power of 3 all over 3, then minus, okay, we can actually eliminate 2 here. We have k raised to the power of 2 all over 1, then plus k all over 1, okay, then minus, then here we have 1 throughout, so here you have 1 all over 3, then plus 1, okay, here you have minus 1 plus 1, all equals to 1 over what? 3. Now to this end, we have k raised to the power of 3 all over 3, then minus k raised to the power of 2 all over 1 plus 1, plus k rather, then minus 1 plus 1 will give us what? 0. So we are only left with what? 1 over 3. Now minus 1 over 3 equals 1 over what? 3. Okay, so to this end, if you bring 1 over 3 to the right hand side, to left hand side, here we have k raised to the power of 3 all over 3, then minus k squared all over 1 plus k minus 1 all over 3 minus 1 all over 3 all equals what? 0. So to this end, we have k cube or raised to the power 3, now plus, minus k raised to the power of 2 plus k, then here we have the same denominator, this will be 3, here you have minus 1, that gives us what? 2, okay, then equals 0. Alright, let us multiply all through by 3 to eliminate this denominator. So here we end up having k cubed minus 3k squared, then plus 3k, then minus 2 equals 0. Okay, so now this has actually led us to a polynomial. Alright, so what we do next here now is to find the factors of this polynomial, and we employ the try and error method, whereby we plug in 1, 2, 3 now, and we are told that k is greater than what? 0. So probably is 1, 2, 3, 4, and so on and so forth. Now to that end, now if we plug in 1 here, you have 1, okay, then minus 3, that will be minus 2, now plus 3, that will be 1, then so it's not equals to 0. Now if we plug in 2, let's try 2 here will be 8, that is 2 raised to the power of 3, 8, minus 3 times 2 raised to the power of that will be 4, now plus 3 times 2 minus 2. Let's see if it will give us 0. It will be 8 minus 12, now plus 6 minus 2 equals 0. So this will be negative 4 plus 4, which will give us what? 0. Okay, so that is it. So it implies that k equals 2, which is one of the factors. Okay, so let us see the other factors of k. So to this end, it implies here that k here will now become k minus 2 equals what? 0. So now let us now come dividing. Here you have k cubed minus 3k squared plus 3k minus 2. So here we have k minus 2. Alright, now using the division for polynomial, so here we have what will multiply by k to give you k cubed, that will be k squared. Here you have k cubed, then minus 2k squared. When we subtract, minus 3k squared minus 2k squared, that will be plus. So here we have minus k squared, bringing down plus 3k. Okay, so what will you multiply by k to give you negative k squared? Then that will be negative k. So here we have negative k squared, then plus 2k. Alright, now when we add, we end up having, when we subtract, we end up having k, then we bring down minus 2. Okay, so to this end here, that will be, this will give us what? 1. 1 times k, we have k minus k will give us what? That is to show you that k minus 2 is a factor. Now here is the other equation. We multiply by x minus 2 to give us this polynomial, and when we take a look at x squared minus k plus 1, now looking at it here, this cannot be factorized, and since this cannot be factorized, they definitely their roots are unreal or probably complex. So to that end, k equals what? 2, since we are told that k is greater than what? 0. So k is 2 as the final answer. Thank you and God bless you.